So the next section that we'll work on is the analysis part, and you can just press the down arrow key, and then we're going to insert some text. So let's press Alt 7 and insert text. And since this is kind of our way of playing with Mathematica and learning more about it, let's take our time and play with it. So the first thing is we found the area of the table, and it was found by multiplying the length times the width. And what I can do is I can press enter, and I can write the equation that I use just for practice. In the future you won't have to do all this, and you can just make it more concise, but since we're learning, I'm gonna go ahead and use some of the options that we have here. So I had the length as 182.50 and then multiplied by 107.25 and then equals, and I'm going to rewrite this again, but I'm going to go ahead and copy and paste it. So I'm going to select this, I'm going to press copy and then paste, and then what I'm going to do is I'm going to select this and I'm going to evaluate in place. So this gives me a little bit of a weird thing with the star and the X, but we'll figure that out later. And notice that it didn't give us the sig figs, so we'll go ahead and fix it. And in this case, my sig figs are only 5, so it's 19573 centimeters, and to add the superscript I can press Control 6 and I get the superscript, which in this case is 3 because it's centimeters cubed. In the following labs, or if you want on your own time, you can figure out how to tell Mathematica to just make it to a certain precision, but for right now we'll fix it for her. So we did some conversions, and you did it by hand in the lab. Let's let Mathematica do it for us. That's the reason that we're using this program. So in here, I press down, and then I'm going to format, and where it says style. And what I want is I want to put input, which kind of already tells me it's Alt 9. So I get this little cursor, and I want Mathematica to do this work for me. So I'm going to press the equal sign, and you should get this orange equal sign button. And this is the freeform text, and I'm going to ask it to take that number that I have up there, 19,573 centimeters, and I can just use the caret for the power, cubed to meters cubed. I can press enter, and it's going to interpret that as input, and it gave me the output in meters cubed. Notice that I get this panel right here. Let's kind of play with it, and let's see what happens when I write simplify units. I get 19.757 liters. But the problem here is that it sort of cut it off for me. So I'm going to go back here where it says quantity, and I'm going to add the 3 because it has 5. And then from right here, I can go all the way to the end and press enter again, and it'll fix it for me. I'm going to do the same down here. I'm going to click after the 7, and I'm going to change the input. So if you've done the tutorials, you know that unit simplify is a function or a built-in command. So I'm going to change the input that it has. Again, I just press enter. Oops. So if you make a mistake like I did, you can always go to edit and undo and it'll fix it. We have to go to the end of the line and press enter. And notice what happens there. So I goofed again. So I can backspace. And what I'm going to want to do there is press shift key and then enter so that it can read it as input. And I made the mistake again of not putting the 3 in there. So it's okay to make mistakes as long as we learn from them, right? So clicking there after a while, press the 3, and I can press shift enter, and it's fixed. Now let's say we wanted it in imperial. So let's go convert to base SI. Click on that arrow and convert to imperial. Turns out it gives it to us in pints. What if I wanted it in inches cubed? I could go click on convert unit, and then new unit can be inches cubed. So I can write in caret cubed, press OK, and now it's interpreting the unit, and it was able to figure out that I meant inches. So now what I'm going to do is I'm going to add some text just to kind of guide us along. So I have to make sure that I press the right key. I think I pressed the wrong one. I can backspace, and if backspace isn't working, I can always delete it. For text, remember that I can go format style, and text was Alt 7, so I'm going to use a shortcut key, Alt 7, and I'm going to say let's make a table to present the values. And again, we're practicing. When you get the hang of this, you won't need to take so much time or even listen to my voice here. So I press enter, and I want to make a table. So remember, I can go to insert, table, and then new, and I want to present all these things that I have. So I had 2 columns, and then let's say 1, 2, 3, 4, 5 rows. Press OK, and then in the first cell I'm going to write units, then I can tab and I'm going to write area, tab again, and so centimeters, and I want the cube, so it's control 6 cubed. I can tab again, and I had 19,573. I'm going to add a decimal just to show that they're significant. Well, actually I don't have to because there's no zeros. And then tab again, and now I have meters, control 6 to get the cubed, tab again, and I have 0.019573 meters cubed, tab again, and I found it out in liters, and that was 41.36, but I only had 5 sig figs, so only up to the 5. Tab again, and then I found it in pints, and when I converted it to pints, I got 1,194.4 pints. So I didn't add enough rows to the table here. So what I can do is I can go back to insert, table, and then add row, or control enter. The next one I'm going to add my inches cubed, so control 6 for the superscript, cubed, and then for inches I had 1,194.4 inches. So again, I made a mistake, but it's really easy to fix this. So I can go right here, and I can actually change these. So it was 19.573 liters, which I already have, and change this one pints, which was the 41.365. So even if you make a mistake, it's really easy to correct it. So I click outside of there and I can press down. I'm going to add some more text, so Alt 7 and part B. So we found the volume of the sphere, and it was found by using the formula. And this is another good reason to use Mathematica, is it's really easy to input mathematical formulas. So V, capital V, equals, and then I want to put pi in there, so palette basic math assistant, and I can go to the symbols and I can find the symbol for pi, and then space so it looks a little bit cleaner, and then R, and then control 6 for the superscript squared, right arrow key, and then I can write a space and then times H. So now right arrow key, and then I can add a space and then equals, just so I can read it easier. But we knew that the radius was just the diameter divided by 2. So now I can input again pi, and then parentheses diameter divided by 2, and it looks kind of tight, so I'm going to add a space. And again, control 6 to make it squared, arrow twice, times H. So now I'm going to press the down arrow key, and I'm going to ask it to evaluate it. So for input, remember I can press Alt 9, and I get the little cursor, and I'm going to write pi with the capital P, and then times 1.900, and then divided by 2, close parentheses, squared, so caret 2, then times 3.000. And then I can press enter, but that won't do anything, so I'm going to backspace, and whenever you want it to read the input, you always press shift, enter, and now it's given me a number. What I could have done is, if I go back to this line of output and I'm here, I could have also pressed Alt 9 to get the little cursor and then press equals. And we want Mathematica to interpret that via online, so what I can do is write pi times and then 1.900 centimeters divided by 2, and then square it, and then times 3.000 centimeters, and then press enter, and it's going to give me the correct units. So let's convert the units again, and let's convert it to meters cubed. So meters cubed, press OK, and now it's converted it for me. Let's go ahead and convert it again. Let's simplify it. It's going to want to put it into liters. So now there we have it in liters. What about to imperial? So it picks quarts. Notice how it's just going to pick whatever it thinks is convenient. Let's convert the unit to inches cubed. So inches cubed, press OK or enter, and now we have it in inches cubed. Okay, so now let's find the density using different units. So let's go ahead and press Alt 7 for text. And so I'm going to write part C. So now let's find the density in different units using the formula. And then I can pick out my row over here. Row space equals mass over volume, period. And I'm going to press down. And since I wanted to evaluate something, I'm going to go ahead and press Alt 9. And the mass that I had for, let's say, iron here was 65.43. And then divided by, and I can use one of the neat tricks in Mathematica, although it should be used sparingly because sometimes if you go back and re-edit it, the input line will be different. But in this case, hopefully we won't have to change anything. And in order for us to tell it to use the input from another part, you use the percent sign. And then the input that we're looking for is the one that had it in terms of centimeters cubed. So that was line 11. So now I can press Shift Enter, and now it gives it to me in centimeters cubed. But let's try something else. Let's go ahead and click on here and let's say put grams in there, and again Shift Enter, and it gives it to me in this really weird way, but it's still grams per centimeters cubed. So it kind of didn't quite read it as grams, but I can fix it over here. So let's say again Alt 9 for input. Let's do equals, and let's write 7.6923, and then grams per centimeters cubed, convert to kilograms per meters cubed. And let's see if it's smart enough to understand. So something happened here with this equal sign. Didn't quite understand it. So the other thing that I can do is write this as click on that little plus sign. So click on the plus sign, freeform input, and I'm going to go ahead and just copy this, or cut it rather. So cut, and then I can just delete this line because I didn't want it, and I can paste it here, and then I can press enter and see if it'll do it for me. So now it gave me the result in kilograms per meters cubed, and then again I can convert it, let's say, to imperial, see what it gives me, and then pounds, inches cubed. So at this point we can do the same thing for the aluminum. So let's do the same thing that we did up there, and again I'm going to add text. So Alt 7, and let's call this part D. So now for aluminum, so again I'm going to press the down key, and I'm going to press Alt 9 for input, and then press equals, and I should get the orange one. And for aluminum, it was pi times 1.900 centimeters squared divided by 2 squared times 8.100 centimeters. And then press enter, and it's going to interpret it for me. And I get it in terms of centimeters. And see, I messed up, but again, the good thing about this is I can just go and change it because that's just centimeters actually. So 1.900 centimeters. Press shift enter. Uh-oh. My bad. Gotta change that to equals. Don't worry, we can fix it. We can fix it. So if you make a mistake like me, and that's often, you can just delete it. Don't let anybody see. And I'm going to go ahead and copy this. So copy and then delete it again because I don't want anybody to see except for you guys. So again, I want input, so Alt 9 and then equals, and then I can paste it and then press enter. And so now I get the proper units. And let's try some other unit conversions. And we can ask it to do meters cubed. Press OK. And we can convert it again. Let's say to liters. And let's convert it again. Let's say, like before we had pints. Let's convert it one more time. See how easy this is. And now inches cubed. Press OK. So now let's input text again to find row. So here's Alt 7 for text. And let's call this part E. And I can just copy what I already put up here. So copy, control, sorry, no control, so just copy, and then paste, and then I'm gonna press down arrow key. And this time I'm gonna do a little different, so I'm gonna do Alt 9, and then I'm gonna say to multiply, so equals, let it interpret everything that I have. So it's 65.11 grams per centimeter grams divided by what I just got up there in centimeters cubed, so 22.966, and that's going to be in centimeters cubed. Press enter and let it interpret it for me. And then let's convert the units again to kilograms per meters cubed. Press OK and it'll convert it for me. Let's convert it in terms of liters, kilograms per liter. And again, it'll convert it for me. Let's convert the unit one more time. Let's say to SI and see what it gives us. I'm sorry, to imperial. And so we get pounds, inches cubed. So let's add in another table. So we're going to add text. So that's Alt 7. And then I'm going to call this part F. So let's make another table to display our results. Remember, we should only have 4 significant figures because of the mass. So press enter, and then we're going to go insert table and new, and in this case we'll have 1, 2, 3, 4, 5, let's say 5 rows and 3 columns. Press OK, and we're going to click on the table. First cell is units, tab, density of iron, tab, density of aluminum, tab. Units are going to be grams per centimeters cubed. So remember Control 6 for the superscript. Tab 7 dot, and let's see, what do we get? So 7.692. And then the density of aluminum was 2.835. Tab, kilograms divided by meters, Control 6 cubed, tab, and then this was 7.692. Then we can tab, and this was 2.835. Tab, let's put kilograms per liter, and this was 7.692. Tab, 2.835. Tab, and then pounds per inches, Control 6 for the superscript, cubed, tab, we got 0.2779. Let me double check by just going up here. 2.779, yep, that's it. And then click on the last one, and we got 0.1024 pounds per inches cubed. So last part, so press down, and I'm going to call this part G. So Alt 7 for more text, and let's say it's going to be, we're going to find the volume and density of our mystery sphere using V equals, and we have 4/3 pi, so I can just find pi over here, and then R, and then Control 6 cubed, but that's also going to be equal to 4/3 pi, and then parentheses the diameter over 2, Control 6 cubed. And we can write again, and for density, rho equals mass over volume. So we can press down, and let's say we couldn't remember what the volume of a sphere was. Well, again, we can use Mathematica's freeform input. So Alt 9 and then equals, and we can ask Mathematica what the volume of a sphere is. Pressing enter, it's reading it, sending it back, and it gives it to us, and it's assuming the radius is A. And if we wanted to, we could ask more things about it. So show all results, for example, gives us all kinds of stuff. We could even plot it and mess with it. So it gives us all these different formulas, matrix form, all kinds of things. So I can hide those results and then press down, And now I can find, I can type in the equation. So I'm going to press Alt 9, and I'm going to have 4/3 times pi with the capital P times 3.800 divided by 2 whole quantity cubed. I can press Shift Enter to evaluate it, and I get this number. So I'm going to add some more text, so Alt 7. So now let's calculate the density. So down, Alt 9, and then I'm going to write 82.90, and then divided by, and then the percent, so that it's the input from line 33, and then Shift Enter, and I get this number. So let's make a pretty table for it. So Alt 7, and then Enter, and again I can go to Insert, Table, New, and this time I'm going to have 2 rows and 2 columns. Press OK. So for this one, I want to span the first column, so Insert, Table, make spanning, and I'm going to say this corresponds to my mystery sphere, and I can easily see that it's going to be, so enter, is aluminum, because I found the density in grams per centimeter cubed. So I gotta hit the arrow key to make it the same size font as 2.885 grams per centimeter cubed. So click outside and press down, and again Alt 7, and we're gonna call this part H. So don't worry, when you do it you won't have to do all these different parts, but we're learning. So let's find the percent error given by the equation. Percent error equals, so you can find this key, and we just want the vertical line, so it's Shift and right underneath the backspace, and it's the accepted value minus the experimental value. So again, this means the absolute value, and then divided by the accepted value, and all this times 100%. So of our iron and aluminum cylinders. So what I can do is I can ask Mathematica to find me what the density should be. So Alt 7 equal sign, oops, wrong one, right? I want to make this Alt 9, and then equal sign, and then let me ask it for the density of iron in grams per centimeters cubed. Press enter, and it'll calculate it, and it'll tell me what it's supposed to be. So I can again press Alt 9, and then I'm going to call the absolute value function, which is ABS, bracket, and then 7.874, which is my accepted value, minus 7.692, and then close bracket, divided by 7.874 times 100, and then I press Shift Enter and I have it evaluated. So let's say now I want to find the density of aluminum, so I'm going to press Alt 9 equal sign density of aluminum in grams per centimeters cubed. Press enter, and notice how it didn't read it, so something happened here that I didn't do right. So let's see if it's this. So equals, there we go, press enter. And then it tells us it's 2.7 grams per centimeters cubed. So again, I'm going to put input, so Alt 9, and then the absolute value function, bracket, 2.7 minus 2.835, close bracket, divided by 2.7 times 100, and then Shift Enter, and it gives us 5. So let's make one final table to express all this. So Alt 7, and let's make a final table down, and again Alt 7, and I'm going to insert table, new, and let's give it 3 rows and 3 columns. So you can tab 2, press OK. Uh-oh. So I didn't want the last one, I only wanted 2 columns. So what I can do here is I can delete the column if I want. If I just click on this and press delete, it goes away. So let's say that the first row is cylinder element, and then %error, tab iron, and this one gave us 2 point, and we should get about 4 sig figs for this. So iron was 2.311, and then for aluminum we got 5.000%. So this concludes this portion. Again, in the future, I'll leave this up to you. You don't have to write all this. You don't have to watch this long tutorial. This was just so that you could learn how to use Mathematica.